Good morning, students. Today we will start a new chapter from your maths subject, that is geometry. This is the first session of this chapter. So at first we'll learn what is actually geometry. What is geometry? So geometry is actually, it is the study of various object. It is the study of various object, its position, shape, size, and many other parameters or many other properties of different type of objects. For example, the point of any object, its surface area, its line, its ray, many things, all about the study of some simple objects, their positions, their shape, and what are their sizes, and most importantly the properties of different objects. That is all we're gonna study in this geometry section. So it is basically the study of the position, shape, size, and other properties of different objects or different figures. This is all about geometry. Now different figures means the figures can be plane figures, the figures can be surface one, the figure can be line, the figure can be ray. So all these comes under these different figures. So we will study their position, their shape, their size, and other properties. So this is all about the geometry. So first figure comes under this geometry section is point. Number one is point. Now what is point? So point is basically a position. It actually making a mark on your paper. That is simply a position, or we can say clearly it is a mark of position. So point is actually, it is a mark of position. It is a mark of position. It has neither length nor width nor any thickness, and it also does not occupies any space. So it has no length, no breadth, or no width, no thickness, and it doesn't occupy any space. That means, suppose this is a figure, and this is a point in the figure. This is a point in the figure. Suppose its name is P. So P is a point in this plane. So it actually making a mark, or it is actually symbolizes a position. It has neither length nor width nor thickness, or it doesn't occupy any space. So number one, it has no length. Number two, no width or no breadth. Number three, it does not occupy space. And lastly, number four, it has no thickness. It simply is a position, that is a mark of position. This is point. So number one figure is point. Number two figure, that is plane. So what is plane? Plane is actually a flat surface. It is actually a flat surface. Plane is actually a flat surface. It is a flat surface. Plane is actually a flat surface. It is a flat surface. Clear? Now a plane has length and width. As it is a flat surface, it has length and width, but it has no thickness. A plane has length and width. A plane has length and width, but no thickness. It has length and width, but it has no thickness. For example, suppose a page of your book, or a surface of a wall, or top of a table, top of a chair. All these are examples of plane. Or suppose it is a blackboard, so it is also a plane. Clear? That means example will be blackboard, surface of blackboard, surface of blackboard, page of any book, or you can say top of a table, all these are plane. That means these are flat surface. These has length and breadth or length and width, but they have no thickness. Clear? So it is all about plane. Now suppose there is a point. The question is, how many how many lines can be drawn through this point? How many lines can be drawn through this point? Suppose there is a point P. The question is, how many lines can be drawn through this point? The question is infinite number of lines. The answer is infinite number of lines or unlimited lines, because through this point we can draw like this. This is a line. We can draw this. This is a line. This is a line. This is a line. You can also draw it like this. You can also draw like this. All these are lines. That means through a given point we can draw infinite number of lines or unlimited number of lines. Clear? So this is plane. So it has a flat surface. Clear? It has length and width, but it has no thickness. So number 2 is plane. Number 3 is surface. Number 3 is surface. What is surface? Now surface also, like plane, surface also length and width, but it has no thickness. Like plane, surface has also length and width, but it has no thickness. So number 1, surface, it has also length and width, but no thickness. Surface has also length and width, but it has no thickness. Now this surface can be of two types, flat and curved. This surface can be of two types. One is flat surface and second one is curved surface. One is flat surface and number 2 is curved surface. But in case of plane is only flat surface. It cannot be curved. In case of plane, the plane is a flat surface. It is not curved. But when come to surface, it can be flat surface, it can be curved surface. So for example of flat surface like blackboard, surface of blackboard, or top of a table, or the outside position of your box. All these are example of flat surface. So number 1 is like top of table, or surface of blackboard, or you can say surface of page of your book, or you can say outside of a box, all these are examples of flat surface. Now in case of curved surface for example will be the cricket ball, the surface of a cricket ball, that is the oval shape. That means it is a flat, it is not a flat surface, it is a curved surface. That means you can write surface of a cricket ball, or you can also say surface of a football. All these are examples of curved surface. That means surface, it has length and width but no thickness, like plane. But the only difference is that plane is a flat surface, but surface can be flat surface and can be curved surface. Clear? So number 3 figure, that is surface. Number 4. So we have studied point, we have studied plane, and we have studied surface. Number 4 is line. Number 4 is line. Number 4 is line. Suppose there is a 2 point, one is A and another one is B. One is A and another one is B. Clear? So line is actually it has actually length. A line has only length. It has neither breadth or width or nor thickness. It has only length. So number 1, line, it has only length. It has only length. It has neither width or breadth nor thickness. It has only length. That means line is a geometrical figure which has only length. It has neither width or breadth nor thickness. Now these A and B, these two, the line is actually when you extend the 2 point in both direction, that means in left side and right side both, then that is a line. That means you have to extend this 2 point. You have to extend this 2 point like this. So it is now a line. This is now a line. This is the A point and this is the B point. That means if both of these points are extended in both direction, then that is a line. So we can say that AB is a line. We can read this as line AB or line BA. That means we will read this as line AB or line BA, and we will simplify, or we will write this figure like this. That means AB, we can write that like this, AB, this is a line. Or we can also like this, BA, this is the symbol of line. In this way we will represent line. So this is the mathematical representation of line, and we will read this as line AB or line BA. But when we will symbolize, or we will depict or represent line in your copy, just write AB and making a arrow over AB in both direction, or you can write also BA and making an arrow over BA in both direction. So this is line. That means the 2 point when extended in both direction, then the geometrical figure is your line. Now this line has no fixed point. This line has no fixed point because A and B, this point are not fixed. You have extended the point A towards left and you have extended the point B towards your right. That means it has no fixed point. Line has no fixed point. Clear? It has no fixed point. It has no fixed point. Clear? Both of these point A and B have to be extended on both sides. That means these points are not fixed. So it is a geometrical figure. It has only length. It has neither width nor breadth nor thickness, and it has also not a fixed point. It doesn't have a fixed point because both of these points are to be extended on both sides. And we will write line as AB, making a arrow sign in both direction over AB, or we can also write BA, making an arrow sign or both direction. Clear? Now this line has two classification or two part. One is straight line and another one is curved line. Straight line is like this. This is a straight line. A and B, they are 2 points. When they are extended in both directions, this is a straight line. This is a straight line. And number 2 will be curved line. Curved line like this. This is a curved line. That means a line which is not straight. That is a curved line. This is a curved line. So there are 2 line classification of lines. One is straight line and number 2 will be curved line. Clear? So number 4, line. This is another geometrical figure. Next, number 5. Number 5 is ray. What is ray? Now ray is actually a part of line. This ray is actually a part of line. Ray is actually a part of line. Now it is a straight line. Ray is actually a straight line that starts from a given fixed point and moves in the same direction. It is a straight line, or more precisely, it is a part of a straight line that starts from a given fixed point and moves in the same direction with the given fixed point. That means ray, it is a straight line. It is a straight line that starts from the given fixed point, that starts from a given fixed point, from a given fixed point, and moves in the same direction, moves in the same direction. That means ray, it is a part of a straight line that starts from a given fixed point and moves in the same direction. Suppose these are 2 points A and B, A and B. Now line is actually when you extend this A and B point towards a same direction, that is actually the ray. That means you can extend the AB towards the left side, or you can extend towards the B, that is towards the right side. But here you have to extend the this AB section in any one direction, in any one direction. That means either you can extend like this, making a arrow sign, or you can also extend the AB position like this towards left side, in any one. You cannot extend A and B in both direction, like in case of a line. In line, the 2 point are extended in both direction, that is in left and right. But in case of ray, these 2 points are to be extended only in this in any one direction. That means either in the left direction or in the right direction. That is actually the ray. That means here in ray, it has only one fixed point. Ray, it has only one fixed point. That means if we consider the number 1 diagram, the fixed point is A. The fixed point is A because you have extended the point B. And in case of second diagram, the fixed point is B. This is the fixed point. You have extended the point A. So in diagram 1, A is actually the initial fixed point. It is the initial fixed point. It is the initial fixed point. And you have extended the point B. In case of diagram 2, B is actually the initial fixed point. B is actually initial fixed point because you have extended the point A. So that is the ray. So in case of ray, they have only one fixed point. That is the initial point. The fixed point is actually the initial point. So in case of ray, it has only one fixed point. It has only one fixed point, and the fixed point is termed as initial fixed point. That is, the fixed point is initial fixed point. Initial fixed point. The fixed point is initial fixed point, and it is extended in any one direction, either in the left side or in the right side. That is, it has extended, it extends in any one direction, in any one direction. This is the ray, and we will represent the ray like this. If you see the diagram 1, the ray will be AB like this, and in case of diagram 2, you will represent the ray as BA, because the A is the fixed point in diagram 1, so the fixed point should be written first. Because in case of diagram 1, just consider the diagram 1, A is the fixed point, initial fixed point. So when you represent ray, just write the initial fixed point first, then the other point, and making an arrow sign over the AB. But in case of diagram 2, B is the initial fixed point, so write initial fixed point first, then the other point, and making an arrow sign. Clear? So this is very important. The arrow sign or the initial fixed point position is very important in case of ray. The initial fixed point should be written first, then the second point, and making an arrow sign, single arrow sign over AB. But in case of diagram 2, here B is the initial fixed point, so initial fixed point should be written first, then the other point, that is BA, making an arrow sign. So if you draw this diagram, your representation, correct representation of ray will be AB arrow, and if you draw this diagram, the correct representation of ray will be BA over arrow sign. Clear? So this is ray, and it is a part of straight line. Next geometrical figure after ray is line segment. Next geometrical figure, number 6, is line segment. Line segment. Now line segment is also a part of a straight line. Like ray, line segment is also a part of a straight line. So it is also a part of straight line. It is also a part of straight line. Okay. Now suppose there are 2 points A and B. These are the 2 points A and B. So this is a line segment, because in line segment it has 2 fixed points. One is A and one is B. These are the 2 fixed points. In case of line, the 2 fixed points are to be extended. That means in left side and in the right side, both of these points are to be extended. In case of line, that means in line there are no fixed point. In case of ray, only one point is extended towards any one side. Clear? That means a ray has only one fixed point. Clear? And that is termed as initial fixed point. But in case of line segment, both of these points remain fixed in their position. That means here no extension is required. The 2 points A and B are already fixed in their position. That is actually the line segment. That means it has 2 fixed points. One is A and another one is B. So line segment has 2 fixed points. It has 2 fixed points. That is, one is A and another one is B. This A and B. Here extension is not required. That means this A and B point need not to be extended. This is the correct diagram of a line segment, and mathematically it is represented as AB and making a bar sign over AB. You can represent line segment like this, or you can also represent line segment like this, making a bar sign over AB or BA. This is line segment. This is how a line segment clearly depicts, or we can represent the line segment like this. So this is all about line segment. Next, this is the 6th geometrical figure. Next, number 7. Number 7 is parallel lines. Parallel lines. What are parallel lines? What is parallel lines, or what are parallel lines? Now, two straight lines are said to be parallel line to each other if they lie in the same plane. If they lie in the same plane and do not meet even when produced up to any extended side. The two straight lines are said to be parallel to each if they lie in the same plane. They have to be lying in the same plane and they do not meet even if you extend the two lines in any one direction. That means suppose these are the 2 points A and B. A and B. So two straight lines. Now straight line means the both of these points are to be extended. So this is a straight line AB, and this is P, and this is Q. So this is another straight line. So both of these straight lines are extended. So if you extend these two straight lines, it will not meet. It will not meet. So these are actually parallel lines. These two lines are actually in the same plane. They lie in the same plane and they do not meet even if you produce these lines up to any extent. So these are actually known as straight lines, and these two combinedly known as parallel lines. That means AB is a straight line, PQ is a straight line. AB itself is a straight line, PQ itself is a straight line. But if you talk about both of these lines, that is AB and PQ, both of these lines are parallel. That means they are parallel to each other. So two straight lines are said to be parallel to each other if they lie in the same plane and do not meet even when produced up to any extent on either side. That means two straight lines are said to be parallel to each other if they lie in the same plane, number one condition, and they should not meet even if you produce these two lines up to any extent. And this is represented as, these two parallel lines are represented as AB parallel PQ. This is the sign of parallel lines. That means AB parallel PQ. This is the sign of parallel lines. That is how we will represent the two parallel lines. That is AB parallel to PQ. Next, number 8. Number 8 geometrical figure, that is intersecting lines. Intersecting lines. Intersecting lines. Now, what are intersecting lines? If two lines lie in the same plane and they are not parallel to each other. If two lines lie in the same plane and they are not parallel to each other, then they are called intersecting lines. Suppose these are the two lines. This line A is a point here and B is a point here. These are two straight lines. Suppose these are one straight line and there is another straight line. Suppose it is a point C and it is a point D. These are another straight line. So these two straight lines, they intersect at this point. They intersect this point. Suppose these are O point. So these two lines are said to be intersecting lines because these two lines are not parallel. They are not parallel. If they are parallel, they will not meet each other. If these two lines are to be parallel lines, they will not meet each other, but they intersect at point O. That means these two lines are not parallel, but they are called intersecting lines. That means intersecting lines are those lines that are not parallel to each other. They will lie in the same plane, but they are not parallel to each other, but they will intersect at one common point, that is point O, and this point is known as intersection point. This point is known as intersecting point or intersection point. Intersecting point or intersection point. Clear? So two lines, so intersecting lines, two lines lie in the same plane. If two lines lie in the same plane but they are not parallel to each other, they are called intersecting lines. They are called intersecting lines. If two lines lie in the same plane but they are not parallel to each other, so they are called as intersecting lines. These two lines are intersecting lines, that is AB and CD are intersecting lines which are intersecting at point O, and point O is actually the intersecting point or intersection point. Clear? Next, number 9. Number 9 geometrical figure. Number 9 geometrical figure, that is collinear points. Collinear points. Collinear points. Now suppose this is a straight line. Suppose this is a straight line. This is a point A. This is point B. This is point C. This is point D, and this is point E. Now what are collinear points? If three or more points lie on the same straight line, then the points are said to be collinear points. Three or more lines, they have to be lying in the same plane or they have to be lying on the same straight line, that are known as collinear points. That means here point A, point B, point C, point D and point E, all total 5 points are there and they are lying on the same straight line. So these are known as collinear points. These are known as collinear points. Collinear points. So what are collinear points? Three or more lines, when three or more lines lie on the same straight line, lie on the same straight line, then they are said to be collinear points. Three or more points lie on the same straight line. Three or more points lie on the same straight line. When three or more points lie on the same straight line, then those points are termed as collinear points. Here all total 5 points are there. So all these points lie on the same straight line. So all these 5 points are collinear points. Now what are non-collinear points? What are non collinear points. What are non-collinear points? When any point or when some points are not lying on the same straight line. When the points are not lying on the same straight line, then they are said to be non-collinear point. Suppose this is a straight line, this is a straight line, that is, suppose this is a straight line AB, this is a straight line, and here is the point P, here is the point Q, suppose here is the point R, here is the point A. So all these points are non-collinear points. That means point P, point Q, point R and point S. These 4 points are non-collinear points, because all these 4 points, that means P, Q, R, S, all these 4 points, they are not lying on the straight line. They are not lying on the straight line. That means all these 4 points are your non-collinear points. Clear? Next, last geometrical figure, that is number 10. Last geometrical figure, that is number 10. Number 10 is concurrent lines. Concurrent lines. Now, what are concurrent lines? If three or more straight lines pass through the same point, if 3 or more straight lines, they are passing through the same point, then that lines are said to be concurrent lines. 3 or more straight lines, those straight lines should be lying in the same plane, and those straight lines should pass through the same point, that is through same common point. Then those lines are said to be concurrent lines. That means if 3 or more straight lines, they lie in the same plane, these straight lines should lie in the same plane. 3 or more straight lines that lie in the same plane pass through the same point, are called concurrent lines. That means if 3 or more straight lines in the same plane, they lie in the same plane. If 3 or more straight lines, they lie in the same plane, they pass through the same point, then they are called concurrent lines. If 3 or more straight lines pass through the same point and those straight lines are to be lied in the same plane, then they are called concurrent lines. And the common point through which they are passing, that common point will be termed as point of concurrence. That means suppose this is a point, and from this point all these straight lines are passing. All these straight lines are passing. Suppose this is a AB straight line. Suppose this is EF. Suppose this is PQ. And suppose this is RS. So all these straight lines are passing through a common point. So this common point is suppose O. So this O is called the point of concurrence. That means all these 4 straight lines passes through the same common point, which is termed as O, and this O is actually the point of concurrence, and all these 4 lines are termed as concurrent lines. Clear? So this is all about the theory part of this fundamental concept, that is geometry section. In the next session we will solve directly questions that is based on this theory. Clear? Thank you.